Hi, welcome to all. Today we are knowing about scientific method. First, what do you mean by science? Science means knowledge. It is the effort to discover and increase human understanding of how the physical world works. That means it is the knowledge gained from using observations and experiments to describe and explain the world around us. The process of scientific study or conducting your research may follow some steps. It is conducted in a step by step manner. These methods are commonly known as scientific methods. Scientific method is the process to find answers to questions about the world around us. Any method of selecting a problem scientifically following some logical step may be called as scientific method. The scientific method involves a series of steps that are used to investigate a natural occurrence. Scientific method consists of these following methods. There are 9 steps listed here: sensing the problem, defining the problem, analyzing the problem, interpreting data, formulation of hypothesis, selecting and testing most likely hypothesis, drawing conclusions and generalization, and the last, application of generalization to new situations. In detail, first, sensing the problem. What do you want to know? That is the first matter in sensing a problem. Use observations you have made to write a question that address the problem so topic you want to investigate. The setting up of a problem may be a cooperative approach of both teacher and student. Teacher should provide such situations in which students feel the need of asking some question. Teacher may also put such questions which require reflective thinking and reasoning on the part of his students, and this may become a problem for students to solve. The teacher opens up a field for investigation and asks the students to suggest places where problem might exist. It is important that a teacher should accept the problem suggested by students, which he feels that it is up to his needs, capabilities, and intelligence of the students. Also consider the interest of students and availability of material to solve the problem. That is also one of the important criteria. Then the another major aspect is that the problem should fit in the curriculum and should appeal to majority of students in the class. We can describe sensing the problem by using a small example. That is, a teacher demonstrated an experiment to the students to show that water boils at low temperature under low pressure. For demonstrating that, he take a flask and fill it half with water, boils water over a flame, then corks the flask, invert it and pours cold water on the flask. Students observe the process carefully and see that water has begun to boil again and again. They are clearly observing the experiment demonstrated by the teacher. There may arise some questions like why water boiling, what is the reason for pouring the cold water, etc. Their clear observation leads to sensing the problem. They at once sense a problem for themselves of finding out the reason and explanation of what they have seen. This is sensing the problem. And the next one, defining the problem. Students must define the problem in concise, definite, and clear language. Keywords present in the problem help to understand easily. The statement of problem is also important while defining a problem. For that, a teacher should ask the students to state the problem. So students can conduct a discussion or making some questions from the above example. We can say that why water is boiling, why did water boil first, or why did water boil in the flask when cold water is poured over the inverted flask. The last question. In fact, the problem is surely the last one. Because why water boiled when cold water poured through the flask? Every student may arise this question. In fact, the problem which should be solved and at the same time it is in the accordance with the criteria of stating the problem. So this problem is accepted and students start analyzing it. The questions raised by students and their discussion leads to statement of the problem. Then they take the problem and analyzing it. So the next step is analyzing the problem. The identified keywords and phrases help the students to study the problem. By analyzing the problem, we can answer the questions like, is your data reliable? Does it make sense? Etc. Here in this example, we can say that boiling point of water is obviously the keyword for problem. Keywords are actually act as hints. Through these keywords, we can collect lot of information. So the next step is collection of data. The teacher suggests references on the problem. Students collect references and evidences bearing upon their problem. That is important in collection of data. And it is a good opportunity for teacher to guide students because it may lead to develop variety of skills and techniques. Which, how, who, when are important in data collection. These questions gives lot of information regarding the problem. Then teacher can ask students to use variety of methods for gathering data such as reading books, conducting field trips, discussing with experts, conducting experiments, etc. Do you remember the next step? We are now describing what are the steps used in scientific methods. We discussed sensing the problem, defining the problem, analyzing the problem, collecting the data, and the next step is interpreting the data. What do you mean by interpretation? Drawing inferences from the collected facts after analytical or experimental study. It critically examined with references to relevance, clarity, appropriateness, etc. We can say that it is an important and at the same time a difficult step, for it involves reflective thinking and complex of skills and abilities. Students require a lot of practice in interpreting the data. The students organize the data by similarity and differences and plan experiments to answer questions and test ideas. Interpretation may be qualitative and quantitative. Some of the statistical methods or measurements may difficult for students to interpret, but it is very important at the same time little difficult to students. Next step, formulation of tentative hypothesis. What do you mean by hypothesis? Hypotheses are our prediction for the outcome of the experiment. What do you think will happen? When we conducting an experiment, we predict that the outcome of this experiment may be this or that. That prediction is known as hypothesis. It's a possible answer to the problem or question. The important aspect of hypothesis is that it is based on the observations and should be testable. From the above mentioned example, we can state so many hypotheses regarding the boiling point of water. The hypothesis may be water will also boil when flask is not inverted, when flask is not boiled but only warmed, when hot water is poured over the inverted flask containing boiled water or cold water, when cold water is poured over the flask containing cold water, when cold water is poured over the inverted flask containing boiled water. The last one is always in our mind to know about the prediction. Maybe the cold water poured over the flask leads to our conclusion. So we have to test this hypothesis, very important. So the next step is selecting and testing of most likely hypothesis. Selecting the most likely hypothesis out of the number of hypotheses requires special skills and involves analyzing, selecting and interpreting the relevant data, judging pertinence or significance of data for immediate problem. Students can select most suitable hypothesis by rejecting the others through discussion and conducting experiments. And also the selected hypothesis again tested experimentally to find out the truth. Because scientific study or science needs accuracy. Exactness is the important characteristics of science. So the selected hypothesis becomes subjected to further statistical test. It gives accurate result. So statistical test is important in testing hypothesis and selecting most suitable one. The example clearly shows that. From this example, we can say that students have found that water begins to boil again in an inverted flask when cold water is poured over it. In no other condition this was possible, and so all other hypotheses were rejected. We selected the most suitable one from the above mentioned lot of statements or lot of hypotheses. Next step, drawing conclusions and making generalizations. The tested hypothesis, if accepted, leads to the conclusion to be formed. Generalizations can be made if similar set of experiments also shows the same result. In fact, the tested hypothesis is the conclusion to be reached at. Some demonstrations can be arranged to arrive at the conclusion. The generalization can be made by arranging a set of experiments which also show the same conclusion already reached at. In this example, we already told that the experiments conducting at low temperature and varying pressure. So the effect of varying pressure on boiling point of water can be found out by conducting experiments. From these conditions, one can generalize that pressure has direct influence or direct effect on the boiling point of water. That means when pressure increases, boiling point also increases. When pressure decreases, boiling point also decreases. They can uh, generalize this by conducting different experiments, and they always provided the same result. How can we lead this step to another one? Because another one is very important, application of generalization to new ideas. How can we use the generalized ideas into our daily life situation? The generalizations regarding feasible solution to a given problem are then applied in new practical situations. The students should apply the generalization to their daily life because it is the important step uh, in solving so many daily life problems. For example, the students will apply the generalization that increase in pressure increases boiling point of water and decreases in pressure decreases the boiling point of water. To explain the reason of in our daily life situation, we are familiar with this question. Why is it difficult to cook meat and pulses at higher altitudes? Or another example like why do the pulses etc. take lesser time for cooking in pressure cooker? In this way, the students will apply the generalization to other life situations. Moreover, the application of the principle will help in verifying the principles itself. This is a deductive approach in which the students can predict and explain different phenomena on the basis of principles. So, it's quite clear from the above discussion that scientific method involves a definite and set procedure of attacking the problem, finding out its solution inductively, and lastly testing the adequacy of the generalization by deductive approach. Next, what are the advantages of scientific method? It is based on empirical evidence. It is proof and verification, found by reasoning and observation, reliable at finding the truth. Scientists are impartial, cautious with theories that are backed up. And we know that it may also have some disadvantages. They are: nothing has full knowledge of the world. Senses can deceive us. Science only provides us with an incomplete picture of the world. Scientists can never be completely unbiased. Science is not free from error. No way of knowing what is real. Some things could be illusions. Theories have to sometimes be interpreted. Example, data is interpreted. Think, do you remember all these 9 steps? Which are they? Sensing the problem, defining the problem, analyzing the problem, collecting the data, interpreting the data, formulation of most suitable hypothesis, selecting and testing the most likely hypothesis, drawing conclusions and making generalizations, and the last one, application of generalization to new situations. Hope you can understand the presentation. Thank you.